Shall we start? So I'm going to talk about backbone global internet privacy and the mixnet smart contracts on the exchange. Who am I? I'm John, developer, do backend stuff, Rust, most of the time. And before we're going to talk about these things that I mentioned, about these contracts on the chain, I will give a quick overview, or talk a little bit more general, what NIM, the NIM platform, what it is, why we do it, and we're going to slowly drill down into the more technical contract-related stuff. So basically, what we're doing with NIM is that we're building infrastructure to protect against mass surveillance. You know, things like end-to-end encryption, you feel it's safe using end-to-end encryption, at least for times read what you're sending. But these days, the surveillance that happens online is so extensive that it's basically science fiction not too long ago. And you can still there's so much metadata leakage, and like if you manage to monitor the internet at the packet level at the large enough scale, you can usually sort of compromise these sort of internal encryption schemes. And it's not just the NSA these days, any medium-sized government or a lot of companies can do this continent or global monitoring of internet traffic at the packet level. They can correlate who according to who. And this is, from a surveillance perspective, that's sometimes more important, usually more important than what Mark is saying. And things like VPNs don't really provide any anonymity or privacy. At best, they remove the point of failure. So now we have to trust the VPN provider, which you have no idea who it is, probably, and maybe you can use it to circumvent some geo restrictions on Netflix or something like that. But it doesn't really give you any privacy. And stuff like Tor, which is much better, a big fan of Tor. Even then, Tor, even though it hides the traffic, these days now that surveillance is so everywhere and so global, means that you can still correlate to end-to-end correlation. You can still see, you can still match in and outputs. You can still see what you're doing and why, even though you talk. So, and this sort of development, now that surveillance has become more and more sort of normalized in a sense, there is an interesting historical sort of interesting historical situation that happened, which is sort of mirrors what sort of I think will happen in the future. Is that if you remember back in the olden days, before encryption was common, like most things on the internet was clear text, and it was only with the sort of bold adoption of TLS or SSL, what it used to be called, that things like e-commerce became feasible, because you don't really want to spend money on the internet when the criminals can steal with your stuff. So there's more to it than just avoiding surveillance. You want privacy privacy is the enabler. So I think that this will open up a lot of doors for the future. So, and I think that there is a big amount of privacy, more than you think. A lot of people think that who cares about privacy, who cares about monitoring, Google knows everything I do anyway. But the fact of the matter is that Tor sees a lot of traffic, and a lot of people use VPNs, not just for watching Netflix, but actually for privacy as well. And Tor saw a lot of growth a couple of years ago, especially post Snowden revelations. But Tor comes from an era pre-blockchain, so it suffers from the infrastructure, suffers from the problem that it assumes that nodes, people running Tor nodes, do it on their good news for the offer, greatly good. So there's no incentive really to run nodes with the capacity in networks sort of plateaued about 10 years ago. And that's really grown because there's only so many people who are willing to run nodes for the greater good. And you see end-to-end encrypted messaging service like Signal are still seeing heavy growth, especially after things started becoming US, for example. So people value this. Like this is people want privacy. So what is the NIM platform? So the NIM platform is basically always speaking two components. It's a decentralized incentivized mixnet plus private credentials. I will focus on the first part here. The first part is a network or like a network layer thing, whereas the other is the private credentials or more application layer thing. I mean, for the whole platform, you need both. I'm not going to spend too much time on this credentials, but basically you want to unlink what we do at packet level using the mixnet and the transactions on the chain. So what is this mixnet? So here we have a picture of a few existing technologies. Like here you see VPNs, so here you see the traffic, the dots for things data, and you can see them bunched together, and there's timing and sizing patterns, which is clearly visible. And also, when you give up trust to this guy in the middle, assume that that person is a good one, so they have no idea knowing. So this doesn't really give you much privacy. Again, that's why it's and you can circumvent some simple restrictions maybe, but it doesn't give you the privacy. Tor, which is better, of course, here you have Tor, Tor is you don't know it's an overlay network, you have these nodes here, you send your data to this node called circuit through these nodes, you send your data through it, and it is layer encrypted so that on each hop you unwrap layer of encryption, so that you can't trace what goes through the overlay network. But still, it suffers from the same problem where you have, here you can see, you can correlate what goes in and what goes out because of patterns and the size and timing and general metadata leakage. So the NIM mixnet takes this a step further. So you see here at the top. So unlike Tor, which opens up a circuit through the mixnet and sends everything through like this, the mixnet can get to a packet individually. They're all going different ways. You bunch up the data into these identically sized packets, strings packets, same packet format as in Lightning Network, for example. So that you can't really correlate anymore and goes in and goes out. Instead, you can for example, it adds, so in addition to multiple hops, you have cover traffic as well, which is basically background noise in the data, which is something that also you could see, depending on the amount of real traffic in the network, more or less cover traffic. So that's overhead. You add the data here, the packets here, also shuffled. So because here you can see this correlation between input and output, of course, in size and timing. And by making these the same, you remove some of this correlation, but you also still need to reorder and mix the packets time to fully anonymize them and make them unlinkable so you don't have input and outputs. This is done by you adding random delays and hops, and the thing about that is that these hops are set by the client sends them, so that you can make this tolerable, so the user can say that, oh, we want to you make a compromise between latency and privacy, basically, and it's configurable by the client. What else? Yeah, and also unlike Tor, this is scalable in the sense that these nodes here are in 3 layers, and when capacity or the demand for capacity increases, more there's to scale up as needed. So it's another picture, basically showing the same thing. You have the user, with your data coming in to your client, like benchmark in the Sphinx packet, mixnet on the other side. And have multiple hops, power traffic, farming obfuscation. Not all let's note, particularly on traffic. We have some waiting ones, but that depends on the token economics, which we'll get to. Right, and then yes, this first part was about the mixnet. We have a token as well. There's everyone like tokens. And the thing that that's supposed to solve is this incentivization that we want to create capacity when there is demand. And it works the way is that there's a few things this solves. First, it solves that so mixed nodes, as a mixed node operator running those mixed nodes, you stake your tokens for sort of reputation. For your reputation, basically, and by being part of the active set that allows traffic here, you get token of the reward, encourage people running these mixed nodes, and also this is tested, so you have sort of like mixing type thing going on where because these packets are indistinguishable in here. These are all Sphinx packets, and so you can easily send measurement traffic through, to loop measurement traffic through there, and you can see which mixed nodes are actually relaying your data correctly. So by participating in mixing traffic, you get rewards. That's the idea. Yeah, so the full life cycle of this token economics is that in addition for mixed nodes getting these rewards for participating network, users also have to pay to access the capacity of the network. You do this by buying bandwidth credentials, which was that thing I mentioned earlier. Currently, this is all running as well. We have a running mainnet which works. It's not paperware. Currently, it's free to use, but we give rewards as a mixed node. And also, see, we have validators as well. So I'm gonna just show this picture again about the mixed net, because the blockchain part comes in here where you have a chain, it's the next chain with some validators that controls basically the business logic, of the mixed nets. It controls who are participating in the mixed traffic, who organizes rewards, things like that. So the validators make sure that client pays the tokens to use the network, and we make sure that mixed nodes are rewarded appropriately. In short, about ZK names. This is related to ZK names. It's basically these bandwidth credentials I mentioned before at the application level. This is typically it's all on its own, not super relevant to what I will talk about, so we can skip that. I'm so strange. The layout of the slides be broken, but okay, so this is supposed to show the token flow. Yeah, so here again, this is a similar picture to what we have before. You have the mixnet here, you have the user here, encrypted packets, this packet, you send them to the gateway. The gateway is the entry and exit nodes. Gateways are like mixed nodes, except they also redeem these bandwidth credentials, but they basically the same. Up there, you have the blockchain, the next chain, which controls the mixnet, the rewards, the mixnets. They also do these measurements, for the measurements of the mixnet to make sure that they are mixing traffic correctly, and they redeem, convert million tokens to bandwidth credentials. that the user can use. But yeah, as mentioned before, currently on mainnet, this is free for users to use. But mixnet do get this in it. So these contracts that I mentioned in the title, they occur over here. That chain over there, blockchains, they are they're the business logic of the chain. They control these who are doing mixed nodes for configuring traffic or the gateways and things like that. And the are AwesomWasm contracts, primarily two contracts, mixnet contract and the investment contract. They're decently sized compared to AwesomWasm Berlin, but they're basically the limit of the kind of the like max size of AwesomWasm. They're pretty neat in the sense that they are easily upgradable, and also they have this nice property of that down the line, the whole project could become a DAO style organization where the community can have one of the next sense of contract changes, which is quite attractive. And downside is things like epoch handling is triggering it's manual. Yeah, now I mentioned that there's the validators aside of running the normal Cosmos validators, also run what we call the PI, which is sort of the mixnet specific parts that the validators move around. Yeah, so okay, so we found this contract then. So the mixnet contract, what does it do? Basically a directory of the mixnets and gateways, where we want to be a mixnet operator, we need to register, deposit, stake the funds, and it goes to a contract. The contract keeps track of the active sets, which nodes are active participating in mixing traffic. That will depend on who gets rewards. The mixnet contract does rewarding as well, giving some inputs from the performance data, as epoch, and stuff like that. So it's a glorified service directory, I guess. So it means that thus bonding is our term for when you, as a mixnet operator, when you stake your tokens with the contract to commit to running a mixnode. So that means that the contracts need to keep track of nonces to be able to defend against replay attacks. It also keeps like if you want to participate, contribute, but you don't want to run a mixed node, you can delegate tokens to one of the existing mixed nodes. So it really works that way. It keeps the economic security that way. And this is also something that this contract then needs to keep track of. Because the total stake for the mixed node, together with the uptime, as determined by these measurement data, will then determine the probability to be in the active set. Yeah, the rewarding time, the mixed contract has really rewarding on a rolling 1 hour interval. It's roughly 1 hour. It's on by block times, and this. Well, the epoch is 1 hour. There's also something that we call the interval, which is longer, about a month, which is mainly related to these staking parameters. Global parameters, staking supply. But basically, every hour, contract goes through this big epoch change, which means that changing the active set, rewarding, and all that stuff. There's another contract, it's the vesting contracts, which we wanted to allow also vesting tokens to be used for staking. So from the chain's perspective, they are liquid, but they're locked up in contracts. That's a lot of complexity, but it's just something with I think. You actually this first. So this thing that's like a big chunk of this contract does, the mixed contract, is this 1000 epoch that I talked about. It becomes like every hour, we have to the new API component of the validator will wait for epoch to finish, and then we we send a transaction to kick off the epoch transition, release the contract and false we're doing. It will the API part of the validation will feed in measurement data to the contract, which then will determine the rewards for that past epoch. You will go through all the pending events, such as new politics notes, because these changes only happen at the change of the epoch. You will then found epoch, set the new reward set, goes with layers, because if you remember these mix nodes, they were in common 3 layers. So you want to move around as well. So yeah. So, we went through a big rewrite of our contract as well. It was like it turned out that the way wasn't ideal. We did a naive implementation after the rewarding, because the rewarding meant to have to compare every possible works to determine compounding, and that was unsustainable. So the rewrite basically, but it went quite smoothly, and it's like the thing to work with. Experience learned, I guess. I think that's it.